So I think screen share.
Okay, sir. Fine.
Okay, sir.
ஒரு 2 minutes ஆரம்பிச்சலாம் சார் 2 o'clock.
Okay, sir. Okay, sir. Take your own time, sir.
Okay. Thank you. Sweta ma'am.
Hi, sir.
Start பண்ணிடலாமா?
Okay, sir.
Start பண்ணிடுங்க ma'am.
Okay. So, good afternoon to everyone present here. So, there is a famous quote which was quoted by Mary Forleo. Success doesn't come from what you do occasionally. It comes from what you do consistently. So, with this quote, we'll start day 2, second session of AICT sponsored short-term training program on mission vision for entrepreneurs launching startups with low seed fund by EC Department, PIG. So it's my honor to introduce the speaker for the session, Mr. Sabrinath Premlal, CEO, Respro Lab, Chennai. About himself, he has completed his bachelor degree triply from Magna College of Engineering, and also he got his master degree in embedded system from Anna University. So he's having a decade of experience in embedded hardware, broad design engineering, IoT solution, served in leadership position for automation projects with several industry institutions, experienced divisioning, costing, and executing projects from inception to launch, and is able to provide a structured framework to analyze complex situations into a simple strategic imperatives. So with this huge profile and introduction about himself, let me hand over the session to Sir to take over.
Yeah, thank you, madam. And
Yeah.
thank you, sir. So better today I'll be connecting about the object recognition for the startup, and also one more session for the pattern recognition for startup. Okay, so better I just share my screen, then I can start it. Yeah. So whenever I'm start saying about the object recognition, okay. So far I were connected to how I mean the hands-on session on most of the programming logics with the different algo. But today I will be connecting with somewhat bit different, okay, with some use cases and the real-time cases which we were connected to the different clients, okay, and based on that we stimulated some mechanism, and we stimulated some data for those objects to recognize, and we had a great experience with that business. Okay. Practically, we were connected to the retail industries. We were connected to the manufacturing. Okay. So these are the cases where we kickstarted and we initiated the process, and we got a successful result. Okay. So everything is it's a sort of an image processing. Okay. So previously, before that image processing, if if you are you might have, while you are doing your engineering, you might have detected some iron pieces by dragging a magnet, okay, in your robot or something else. Okay, then it can able to detect the iron pieces at the side or the roadsides. So these are all a kickstart of the recognition. Okay, so particular metal or particular material is recognized. Okay, so similarly we are going to connect with object recognition. Okay, so practically how we will do and what are those methodologies, and also I'll show some demos. Okay, practically if I'm going to run the deep learning, practically it will take more than 20 to 30 minutes to train and run it. So better I show the direct output, and even you can have different output from the GitHub. Okay, even around 1 year back I went to a college. Okay, so I forgot the college. I think it's Sri Ramar. I forgot the college exactly. Okay, there a faculty said that he is in the position to do a PhD in those. So he started giving the idea of what's his PhD is. Okay, based on the year. Okay, so he has to recognize some pattern based on the scanned images. So that's what. Once he said the next within 5 minutes we took via the GitHub. Okay, all the code is ready with the entire output. So he said, "This is what I'm doing in my PhD." So what I'm trying to say is, everything is available in the internet. The one and only thing is we need to tap the right program such a way that it should match your objective. Okay, even while we are doing, okay, we can't do all the stuff. So we are in the position to create the ideation space. Okay, since I'm connecting to the most of the startups, so we have to connect with the proper ideation space. So then only the investor, or you can able to connect to the crowdfunding. Okay, all these things you can able to do it, and you can able to start your startup. Okay, so better I go out with this topic, and I'll come back and I'll explain those experience in detail. Okay, so practically the object recognition, which involves the identifying the objects in the photographs, not only in the photographs, in any digital media like the video processing also we can able to see. Okay, practically an object recognition, we can say that a system finds out object in the real world from an image of the world. Okay, using the object which are known as a bit prior. Okay, this task surprisingly difficult actually. Okay, because the humans perform the object recognition effortlessly and instantaneously. Even in this algorithm, description of the task for implementation on machine can be very difficult. So we can connect with the different recognition tasks that vision may need to perform. we can analyze the complexity of the task and present approach useful in the different phases of the recognition task. Okay, even I can say the object recognition problem can also be defined as a labeling problem based on the model of known objects. Because normally when we are given an image containing one or more object of interest, I mean at the background, a set of label corresponding to a set of model knowns to the system actually. This system should assign the correct label to the region or to set the region in the image. The object recognition problem closely tied to the segmentation problem. Okay. Without at least partial recognition of the object, segmentation cannot be done. Without the segmentation, object recognition is not possible. So this is something like a deadlock, and we can have in detail about these things. Okay. So here I'm showing some pic. Okay, this is the components of the object recognition. Okay. So once the image came, the feature detector, okay, it takes the corresponding feature, hypothesis formation, okay, it identifies the candidate object or model base in the hypothesis verification, and it connects to the object class. I'll be explaining more on each and every thing. Okay, so here you can able to see the feature detector. In this feature detector, which feature should be detected, that must be specified. Okay, in a particular image we can have a n number of features, and which feature it should be detected and how they can be detected reliably. Okay, so how reliable it is. Okay, this also we need to focus. Okay, the most feature can be computed into two-dimensional image, but they are related to three-dimensional characteristics of object actually. Okay, so I mean what I'm trying to say is, if you are taking a picture, it's a three-dimensional picture, but once you took the picture, this is somewhat like a two-dimensional picture. So you need to recognize that two-dimensional spatial units, but actually this is from a three-dimensional space. Due to the nature of the image formation process, some features are easy to compute reliably, and also while others are very difficult. Okay, feature detection issue when discussed, I mean, it will lead to different issues. Here itself, the lots of challenges is there. Okay, and in this future detector, we can say the feature model matching also. In this feature model matching, how features in the image to be matched to the models in the database. That's what I'm connecting to the model base also. Okay, so how it can be connected. Okay, how it will be matched to the corresponding data. In most object recognition tasks, there are many features and numerous objects. Even I can say an exhaustive matching approach will solve the recognition problem, but it will be too slow to be useful. Okay, the effectiveness and features and efficiency of the matching techniques must be considered to develop these approaches. So that's what the model base or the model matching should be focused. And in terms of the hypothesis formation, so here we can say about I mean, how can it how to set the object based on the feature matchings to be selected. Okay, so how the probability to be assigned to each possible object. Okay, so if a image is came, how you are probably connecting that particular region, or I mean, if I'm having a big image, okay, so I need to connect, I mean, let's assume I just draw a diagram over here. So assume you are having this much of images, you need to recognize some pattern like this. Okay, so let's assume some face. Okay, so you need to recognize this face, but you will be capturing from everywhere. Okay, so how probably this face matches with the pixel with what you are having. Even I'll be showing some demo also, and I'll be asking you to do some calculation also. So there you can able to recognize in a better way. So how much label it connects. So that's the formation or object-based formation. Okay, or we can say the probability to assign for each possible objects. Okay, practically this is to reduce the size of the search space. So instead of searching everything, this identifies this space, and in this space, if I want to focus the eye only, this will be captured. If a human face is there, okay, if I'm going to recognize the object, so I can able to recognize the eye only. Okay, like this I can able to perform. Okay, so this step uses the knowledge of the application domain to assign some kind of probability or confidence measure to different object in the domain. This measure can reflect the likelihood of the presence of the object based on the detected features. So that's what we can say about the hypothesis formation. And also in verification, how can the object models to be used to select the most likely object from the set of probable object in a given image. Okay. This is what I am trying to say. If I'm considering the image, and if I'm having a database, I'm connecting this, and here only the verification process is done, both are is equating or not. Okay, so here the hypothesis to verify the presence of the object. Okay, if the model are geometric, okay, it is easy to precise, or even we can say the verify the objects using the camera location, other skin parameters. Okay, so these are all the different hypothesis verification. Then only we can able to class this object under which class and whether the object is detected or not. Okay, this is what we can able to say about the basic ideology of the components under the object recognition. Even here also, if you are giving some image, okay, or if you are giving some model representation, okay, how should the objects be represented in the model database? Okay, so this we need to focus. And also what are the important attributes, or we can say the features of the objects that must be captured in this model. Even we can say the geometric description may be available, or may also be efficient, while for other classes one may have to rely on generic or functional feature. The representation of the object should capture or relevant every information, okay, which are relevant to that, okay, without any redundancies, and should organize this information in a form that allows to access by different components of the object recognition system. So this we need to focus. Okay, these are all the basic ideology, these are the basic block of how for the recognition. And even if I'm considering for the complexity in the object recognition, okay, so we can connect with the different complexity, scene consistency, image model spaces, number of objects in the model database, also number of objects in an image, and the possible of collision also. So these are the things we need to focus. If I say about the screen consistency, okay, the scene complexity will depend on whether the images are occurred in a similar condition as the model, or seen in earlier chapter. Okay, even under the different scene condition, the performance of the different feature detect will significantly different. The nature of the, I mean, there are several things are there. while we are connecting the complexity of the object recognition. Even images can also be obtained. I mean, that's what I said, right? Images can be obtained in a three-dimensional way, but it is considering the two-dimensional. Okay, in this case, the model uses the two-dimensional characteristics. Oh, 1 minute, please. So I'll close the door. Okay, because of raining. 1 minute. Yeah, sorry. Okay. So that's what about the basic ideology of model. Here I will be connecting with the computer vision task. So here I'm mentioning with three different ways: image classification, object localization, and object detection. Okay. So in this, okay, practically the image classification involves assigning a class label to an image. Okay, whereas we can say the object localization involves drawing a boundary box around one or more objects in an image. Okay, even the object detection is more challenging and combines these two tasks and draws a bounding box, okay, around each object of interest of the image. Okay, so connecting to the corresponding labels also. So practically together the problems are referred as, we can say this is nothing but a object recognition. Okay, so practically the object recognition refers to the collection of a related task for identifying object in the digital photographs. That's what I said in the previous slides also. Whereas if you are connecting with region-based CNN or fast CNN, YOLO, different methodologies are there by connecting the deep learning. Okay, so I'll explain about each and every organization. I mean object detection methodology also. Okay, so that's what while we are connecting the image recognition. Okay, so we need to classify, which requires an algorithm to determine whether the object class are present in the image or not. If it is yes, then we need to connect with the localization, then it's a detection. Okay, so practically object classification predict the type or we can say the class of an object or an image. The input can be, okay, the image with a single object such as a photograph or some videos also, where output is a class label. Okay, one or more integer that is mapped into the class labels also. Okay, whereas for object localization, locate the presence of object in an image and it will indicate their location with the bounding box also. Okay. If I'm connecting the input, an image with one or more objects such as photograph. Okay, here also the photograph we can say, and videos also we can say. The output also one or more bounding boxes. So in image classification, the output will be fed as a class label, whereas localization, it will be one or more bounding boxes. Whereas in object detection, it will locate the presence of object with a bounding box and type of the classes or the classes or the labeling of the located objects in an image also we can able to say. Here also the input as photograph or video, everything is a photograph or video. So practically in output we can say it will be connecting to the bounding box with a defined point like a defined width and defined height, and a class label for each bounding box. Okay, so in image classification, it classes the label only. In object localization, it classes with one or more bounding boxes. Okay, whereas in object detection, it classes the label for each bounding box. okay, with corresponding customized height and width. Okay, so this what the object computer vision task to connecting the image classification, object localization, and object detection is helpful. Okay, I'm connecting with some how these object recognition. And so far, what I explained, I'm just explaining. Okay, so previously, while I'm taking the first slide, I explained that without object segmentation, we can't do the object recognition. Okay, without the object recognition, we can do the segmentation. So both are interrelated. Okay, so that's the challenging over here. Okay, even most of the recent innovation in the image recognition problem have come as a part of participation ILSVR tasks also. Okay, so with this task, okay, so the image classification, single object localization, object detection, these are also included even in this image classification, okay, which helps to connect with the algorithm and produce a list of the object category present in the images. And for single object localization, okay, the algorithm produces a list of object category present in the image along with the axis aligned bounding boxes indicating the position and scale of an instance of an object category. And whereas while I'm connecting the detection, here the most of the algorithm produces a list of the object category present in the image along with the axis bounding box indicating the position and scale of every instance of an image category. Okay. So if I'm showing this image, you can able to get. Okay. So previously it was a single image. Okay. So now, I mean here. Okay. So previously it was a normal image. So once I'm connecting the single object localization, okay. So which will identify the object category present. Okay, which will identify the object category is present. Okay, and also connect the bounding boxes like this. Bounding boxes like this, and which will indicate the position and scale of the instance of each object. Okay. After that only, it will connect to the corresponding label. It's a steel drum, it's a folding chair, it's a loudspeaker. Whereas in object detection, okay, which identifies the presence of the image, okay, so folding chair, everything it identifies at the initial stage itself. After the single object localization only, we will be saying it's with the direction, okay, but the position of the each instance for every object category, okay, how the boundary and the labeling and the probability of accuracy. So these things are all we are focusing in the object detection. Okay, so the performance of a model of an image classification is evaluated practically using the mean classification error across the prediction class table also. Okay, the performance of a model for single object localization is evaluated using the distance between the expected and predicted box for expected class, whereas the performance of a model for object recognition is practically evaluated using the precious and recall across each of the best matching boxes, which we can so say that this is nothing but object in the image. Okay, so this what the basic ideology is there. So even I can able to connect with the different algo mechanism also. So by basic, most of you are all knows about CNN. Even though I'll explain that CNN. Okay, so complex, I mean convolution neural network. In this convolution neural network, what are the things that we need to focus? Okay, how this gets identified. So I just explained that slide and I'll come back to this slide. Because if I'm explaining those slides, your understanding will be different while compared to this. So before that, most of you all knows. I mean, I think I assume that most of you knows the ideology of what is machine learning it is, what is deep learning it is. So whenever I takes the session, I'll take some example which is from the teachable machines. So I'll take that. I mean, I'll show that demo also. Okay, and I'll share that link also. Whenever you want to recognize the object, you can able to utilize it. Okay. So by basic, okay. Yeah. By basic, image is connected with different boxes like this. That's what we are saying. This is nothing but pixels. So here you can able to see some different pixels are there. Okay, so I'm not connecting for all the pixels. Okay, here we are having some pixels. So each pixels will have a number. How to calculate those numbers I will explain. But let's assume I'm going to have a image. Okay, so randomly I take a image. Okay, better I'll take my image itself. Sorry, and I will explain with this. So here I'm having my image. Okay. So what happens with the CNN? Sorry. So I took my image. Okay. How the CNN algo is working. So practically it splits in a vertical way. Generally it splits in a vertical way. Okay. You just assume it's connecting like a shred. Okay. It splits in a vertical way. Then again it splits in a horizontal way also. Okay. So once I completed this split, okay, I am taking this first sample. I mean, this is the first sample. This is the second sample. This is the third sample. Okay. So I'm connecting all the odd samples together, even samples together. Okay. Then my image will be a bit different. So something like control is it. Okay. My image looks like this. I'm theoretically explaining. I'll show the practical way also. So my image will looks like this. If I'm joining, I'll be getting two different images. One which is all connected to the ordered spaces, another which are all connected to the even spaces. Then my image will shrink like this. I mean, okay. But this gives maximum accuracy, but practically this is not the real accuracy, but it will give a uh, so if I'm connecting my two images like this, if I'm doing the same process in a horizontal way, same process means I'm going to cut in a horizontal way like this. Okay, I'm going to cut in the horizontal way also. Then practically what happens means my image will come like this, and also another image will come like this. So totally I'll be connecting the even part and odd part together. So totally I converted one image into 4 different images. I compressed this method, my images, such a way that I can, this is for my facial recognition. I mean, not only the facial recognition, this is how the CNN is working. So here I compressed with 4 and 1:4. You can able to compress with 1:20 also. So most of the classification algorithm uses the CNN. Okay, convolution neural network. Even you can able to connect with the ANN also. Whereas CNN is connecting to the scalar unit, whereas ANN is connecting to the vector unit. So here I'll show that now if I'm showing this detail, your understanding level will be a bit different. Okay, let's assume I'm having an image. Okay, this is around 3x3 images. Okay, so to segregate, so practically we are not cutting, so we are compressing. Okay, so we can have a different filter or different kernel. Okay, here I'm going to use this kernel. So I'm taking this entire matrix and placing over this input. Okay, I'm going to do the scalar multiplication or scalar product for corresponding cells for each and every rows and each and every columns. Okay, then a new output will come that will be focused here. So here this is a 3x3 images. So practically the number is 3. Okay, so this is a also 3x3. The practically number is 3. So I'm considering this is m, this is n. Okay, the output will be m minus n plus 1. So 3 minus 3 plus 1 is 1 is the output. It won't give the entire output. This sort, I mean this sort. Okay, I'm taking the filter and I'm going to place it over here. Okay, I'm connecting for the output. Okay, so once I do the dot product, I'll get the single data. So like this, we can have a different detectors. Okay, vertical line detector, horizontal line detector, the corner detector. Whenever you are using this filtration or kernel, both are same. This will be considering with different detectors. Okay, how we are going to utilize this detector? Okay, so here also I can show some. Okay, so here you can able to see it. Okay, this will be identifying the corresponding detector. Okay, this is not an exact image. Okay, like this you can able to get a new matrix. Okay, to get a new matrix, or we can able to show like this also. Okay, sorry, not this one. Yeah, this one. So by this you can able to understand what I am trying to say. Okay, so with this only that processing is kickstarted. So once it is kickstarted, so previously I said right. Okay, if you are doing, okay, so this is the actual matrix and this is the kernel or the filter. So if I'm placing that kernel into the actual matrix, okay, so it does the necessary dot products and it gives the result such a way that this is m, this is n. So 5 minus 3 plus 1 is nothing but a 3. So the output is 3x3. You can able to see this by seeing this picture. You can able to recognize it. Okay, so here you can able to connect not only with the square matrix, you can able to connect with the matrix which is not squared also. You can able to connect. Okay, so if you are connecting, okay, so if you are connecting here, let's assume in this image, this is the midpoint. Okay, for the kernel. So practically you can able to connect the data with the midpoint only. So that's what you are converting 3x3, but you are not considering the methodology for the edges. If you want to connect the methodology for edges, you need to use a methodology called padding mechanism. Okay, so Without padding, this is the actual data. Okay, this is 5, this is 3, 5 minus 3 plus 1. It's a 3 cross 3. Okay, with padding. So I'm going to add a new row at the top and new row at the bottom, and also new column at the right and new column at the left. Okay, so if I'm considering this edge gets deducted. Okay, this is with padding. Like this also you can able to connect. So here practically 1, 2, 3, 4, 5, 6, 7 minus 3 is practically it's 4 plus 1, 5. So the output will be 5 plus 5 matrix. So this sort that CNN mechanism or CNN mathematical calculation will work. This is purely the scalar based one. This is purely scalar based one. Okay. Via this only we will be connecting with different CNN algo mechanism. Okay. So in this CNN algo mechanism, we can here I'm showing example without padding. Okay. If you are increasing the kernel size, you can also increase the kernel size also. Okay. It's up to you. Okay. So with padding, without padding, the same thing that I'm showing here. Okay. So by this way we can able to convert, or we can able to connect these things with the polling also. Okay, here I'm considering this matrix, and here we can able to connect this first matrix determinant, second matrix, everything together, and we can able to convert also. So like this also you can able to poll it. So these are all the basic ideology of how the CNN is working. Okay, once you are clear about the CNN, then you can able to connect with the RCNN and fast CNN, faster CNN. Okay, so these things are all you can able to understand. Okay, so I think you understood about some theoretical concept of how the CNN is working. Okay, now I'll show you. I connect with the slide. Yeah. So few minutes back I just explained these things. So now I am going to connect RCNN. Practically the RCNN refers to regions with CNN features. Regions with CNN features, or we can say like a region-based convolution neural network. Region-based convolution neural network. Okay, practically this is developed by a Grishik scientist. Okay. Okay. So which can able to connect with this RCNN, fastest RCNN. Okay. So better I go with the CNN, RCNN. RCNN can be one or more first. The largest successful application for CNN for the local object recognition, localization, and detection and segmentation processing. Okay, so it can have benchmark data sets. Okay, to achieve this result. Okay, the 200 classes ILSVRC 2013 object detection data sets are used. So this is available in the Keras. Okay, so practically this connecting with the three different models. One is a region proposal. Okay, and the region proposal is nothing but generate and extract the category independent region proposal. Okay, it will connect the bounding boxes also. In next slide, I will showing you with the same mechanism with the necessary block diagram also. And another case is the future extractor. Here it extract the futures from the each candidate region, and you can using a deep learning. Okay, we can able to convert. We can able to get this information. By the deep learning only, we can able to get this equation. And finally, the classifier. We should classify the features as one of the known classes like linear SVM classifier model, or different models are there. Okay, here it suggests the linear. I can able to suggest linear SVM classifier model. Okay. So I said right. Okay. Regions with the CNN features. Okay. Once we got the input, okay, it will connect to the region proposal. Okay. So then it connects to the feature extractors. Okay. What are the deep learning mechanism? Then it connects to the corresponding classifier. The output only connect with the corresponding via the database. Output only connect with the classifying regions. So that's what you are seeing over here. Okay. So practically the computer vision technique used to propose the candidate region also, or for the bounding boxes of potential object images called selective search. Okay, this is what we'll be using with the selective search. Okay, even the feature extracted model also can use. The output of the CNN was around at least, if you are having a 4096 element vector, that describes the content of the image fed to the SVM linear compression. So these things are all we need to focus. It should have at least 4096 element vector, and relatively it's a simple and straightforward application also. Okay, and so this is the easiest way. Okay, so if you need that corresponding GitHub code, I'll share the link to the Professor Arun also. I'll share the link. Okay, you can able to get, if you are using the MATLAB or if you are using the Python. Okay, you can able to get those information. I'll share those necessary links to him, and you can able to get that also. Okay, this is for RCNN. Next is for fast RCNN. Okay, so initially the RCNN is introduced. Okay, but it was a slow process. Then another methodology which is introduced is nothing but a fast RCNN. Okay, here it shows the training is a multiple stage pipeline. Yes. Okay, which involves the preparation and operation of 3 separate models. Okay, so that's what here it's focusing on the preparation and operation of these separate models. And here training, while we are connecting the training, okay, the deep CNN will be used on so many region proposal. So per image is practically slow. Okay, making prediction or the detection with the deep learning CNN, it's a bit slow, but the faster accuracy. So that's what here these things are all connected in a different multi-stage pipeline, and it will be processed, and at the same time it has to processed. So here in this fast RNCNN, okay, it will be proposed with a single model instead of a pipelining done. The output regions are classified directly. Okay, so the output of a CNN is interpreted fully connected layer, and then model segmented into 2 different output. One for the class prediction. Okay, even I can show like this. Okay, so here we are having an image. So here we are having a deep convolution network. Okay, the role of projection. Okay, this is nothing. The combination is nothing but the convolution feature map. Okay, so by polling. Okay, so the compression mechanism is done. Okay, so the class prediction can be done with the softmax. Okay, and another with the linear output bounding boxes. Okay, so in this process, it should be repeated multiple times for each region of interest in a given image. So in this given image, we will be doing. So the architecture of model is this what. Okay, so here it connects to the deep learning. Okay, and for this also I will share the necessary code, necessary link. Okay, even I will share in the chat also. Okay, then I am connecting to the faster RCNN. If I am connecting the faster RCNN, the convolution neural network for proposing region and type of considered in this region, and also for fast or CNN, the convolution neural filter for extract feature from the proposed regions and outputting the bounding box and class labels. So these are all connected for faster or CNN. Practically, both the models operate on the same output of a deep learning. Okay, the region proposal now act as a attention mechanism for fast or CNN. Okay, informing that second network where to look or to pay attention. Okay, even I can show you that. Okay, so okay, so in this RPN works by taking an output of a pre-trained deep CNN. Okay, so here you can able to see that corresponding RPN. Okay, which will be taking the output of a pre-trained deep CNN. Okay, so which is passing the small network over the feature map. Okay, and outputting multiple regions and class prediction for each. Okay, so in this process, the region proposal are bounding boxes based on that another box are predefined shape designed to accelerate or improve the proposal of the region. The class prediction is practically a binary, which will be indicating the presence of an object. It's called objectness, okay, of the proposed region. So how we are going to propose that particular region? So that's the task over here. Okay, so that's what it will be done in a faster way, and everything connecting with the different pipelining mechanism, such a way that this works with it's not a fast RCN. This is a faster RCN. Okay. So the YOLO model, okay, practically YOLO means you only look once. Okay. By basic, the RCNN model will give the more accuracy. Okay. The YOLO family models are faster, much faster than RCNN. But the accuracy bit will get change. Okay. So in this approach, here you are seeing different grid. I mean different pixel. Okay. So in this approach, it will be connecting to the simple neural network trained from end to end for all the images and takes the photography as input and predicts the bounding boxes and classes label for each bounding boxes directly. This technique offers low predictive accuracy also. Okay, although which operates as practically it operates as a 45 frames per second and up to 155 frames per second for a speed optimization version of this model also. Okay, so here this cell is restricting our bounding boxes. If the center of the bounding falls, okay, practically the center of the bounding falls in the region of the boxes which is present. Okay, so that's what I'm connecting. Okay, here we are connecting the input. Okay, so we are having whenever it detects something, okay, it will bound the boxes. Okay, multiple boundaries happened. Okay, here you can able to see. I'll choose the highlighter. Here you can see that, and I choose the different color also. Okay. So here you can see the dark line also. Maximum bounding is happened where it is happened. So this is what it recognizes, and here also it recognizes the maximum bounding, and here also it recognizes the maximum bounding. The car, the cycle, and the dog. These things are all detected, but it will connect with the n number of bounding boxes. Okay, based on these bounding boxes, okay, this will connect with the probability map. Okay, whether it's a success or not. So how much success it is, based on that success, it will show the corresponding deduction. Okay, the final deduction you might have seen. Okay, so this is the final deduction. Okay, like this, the Ola model family will operates. The Ola model family is operates. Okay, so practically the Ola means you only look once. You only look once. Okay, so these are all the different techniques for the object detection. Still, few more techniques also is there. Okay, so if you are start discussing about this, so practically thousands and thousands of techniques, but I'm connecting the basic ideology. Okay, now I can able to share you by taking a real image and how I'm going to get the data of the corresponding image. I'll be showing you now. Okay, so this methodologies the same thing. Okay, better I go ahead and show this result. So here I'm connecting the Matplotlib and NumPy. This is for data visualization, NumPy for numerical, PL for images. So I'm uploading some images. Okay, so better I just do it now. So it's getting connected and initializing. So this is nothing but a Google Colab. Okay. So then I'm going to upload a image, okay, which is having the brain tumor. So here this is a purely medical image. So now I'll show with some other images. Then I'll show with this the real image also. This is GIF. So I'm just connecting the REST image. Web logo.png. So it is getting uploaded. So this image is a bit big, so that's what it is. It is taking time. 100% is done. Once it's done, I'm verifying like this. So I'm renaming it here. Web underscore logo dot png. So I'm going to run. So this is around 1840 cross 8952. So practically so here is right. Sorry. So 1 crore 64 lakhs 17,680 pixels for this image. Okay. So now I am going to take this image and I am going to get the image data. Get the image data. So I'm not going to disturb my previous code. So in this, I'm opening the corresponding image. Okay. Image means weblogo.png. Logo.png. So I'm not explaining the image processing. I'm just explaining how we can able to do the object recognition. Okay. So how we can able to do those mathematical calculations. Okay. So the day now I'm okay. So better just modify here. So what I'm trying to do is I'm creating a new listicle data and another listicle data new. Okay. I'm going to print the image size so that I'll be getting that width and height. Okay. So practically, if I'm getting those information, okay, I can able to get to the corresponding width and height. Okay. So I'll be printing those width and height. Okay, with that width and height. Okay, I'll be instead of giving some number, I'll be giving the corresponding width and height details. Okay. Practically, X is a width, right? And Y will be similarly, I'm changing, and Y is like HIG. So I'm going to run this. Practically, this will take bit time. The thing is, Y means okay, it took bit time. Okay, it will get all the information. Practically, here we are having this much of column and this much of row. Okay, so finally we are having the total row. So I'm going to print only one row. Okay, I'm going to print only one row. So here you can able to see something is there because in this image, in the last row, everything is a white. So that's what it shows. Everything is a 255. Okay. Okay. So if I'm going to print data new of one, not one, data new thousand. Here you can able to see 250 is there. Suddenly 88 is coming. Okay. The thing is, these things are all blue colors. Again, 88 may come. Yeah, it came here. 88 came. So it connects to the corresponding row. Okay. If I'm connecting the 88 together, if I'm putting into the matrix such a way that, okay, the matrix looks like, or these things are all, the blue color are all 88, the red, white color are all 255. So practically it gives a clear ideology of how these things, this image is processed. So here we are having two colors. Okay. So if I want to verify a particular image or verify a particular segment. So then the calculation. So this is a two different images. If I'm connecting to the medical image, So our calculation might be bit different. Okay, so I'm taking, so this is nothing but 1.jpg. So I'm taking those information. Oh, sorry. And I'm connecting to the raw data also. I'm going to get the height and width. So if I'm going to print this thing, the value gets changed. The value is entirely different. The 0 is nothing but a black. The value is entirely different. So by these things, you can able to verify. Okay. So here we are having some issues. Okay, something we need to recognize it. Okay, this is nothing but a black plot. Let's assume. So via this range, okay, via the x-axis, it ranges from 510 to 580, whereas in y-axis also, and y-axis it ranges from 400 to 460, 400 to 460. So that's what we are changing the value over here. Okay, so for x-axis it's a 500 to 600, 500 to 600, and y-axis it's 400 to 4. It's 580, getting 580. 400 to 500. So in this range only this is detected. So here we need to identify this particular matrix connecting to the corresponding thing. So here I am doing manually. So these things need to be recognized such a way that then only we can able to give a mapping over here. Okay, such a way that this gives a clear bounding at this particular space. Okay, that's what I'm showing. So it's done. Okay. So practically it shows, okay, with the different value. Okay. So if I'm calculating with the entire thing, okay, so let's say I'm going to connect with the data frame. Okay. Then I'll print that corresponding data frame together. Sorry. Oh, okay. So I forgot to load it. Okay. Then I did this. So I'm verifying the data name. Okay. So I'm connecting as a data frame. Yeah. Previously it was shown with a different thing. Okay. So now we can able to visualize it. Okay. How this matrix, if you are visualizing in a bigger fashion, okay. So practically you can able to get where that pattern is. Okay, these things you can able to get it from the image recognition. Okay, so or the object recognition. It's not only the brain tumor. It's not only these things. Okay, even I can give some example, but practically I can show those things. Okay, I can give. I mean, even if I'm connecting the teachable machine. So like this, you can able to recognize it and do the process and define where it is and how many wide. Again, we need to do the necessary all the mathematical calculations such that we can able to identify this is one. And like here also, you can able to connect with the manual based CNN algo. Okay, so we can able to get these are the different ideologies. We can able to get these information also. So better I'll say that I'll be sharing some RCNN links. Okay, I'll share this link and I'll show few more examples also. So if you put in how to handle with the GitHub, you can able to get with how to work with RCNN, fast RCNN, and also faster RCNN. YOLO also. So this is what how this YOLO is working. Previously it will recognize like this. Okay. Then only it will be processed. So here you can able to see the dark color, the dark blocks. Okay, here also you can able to see the dark blocks. Here also you can able to see the dark blocks. These are all recognized. Okay. So we can able to get the information from the different GitHub. So all the programs and coding are all available in the GitHub. The one in place such that how you are going to meet your investor. Okay. So 1 minute. Distribution. So I think I took the different if I'm taking any deep learning concepts, I'll be taking this at the first. Now I'm taking this at the last because I took this demo for most of the work training that I'm giving. So why I'm showing this means, so here it recognized me. So I'm the one who is sitting here. Okay. So I'll be taking some Arduino board. So I'm classifying this. This also purely work with the CNN methodology. So I'm taking, I took the Arduino board sample. Then this is a ARM name. Okay. So I mean the friendly ARM. So I'm going to take the image of this corresponding friendly ARM. So then finally I'm going to add one more class. One more class instance. So I'll be taking a sensor. I'm mentioning it as a sensor. So I'm going to train the model. So even I can show you the different examples also. Practically, while I'm training the model, it will take 20 to 30 minutes. I'm sorry, 2 to 3 minutes. Based on the internet speed, yeah, it's taking. Yeah. So here you can see, okay, these are all the labeled data sets. So these are the non-labeled data set. Okay, via this image video processing, it start identifying whether who is it, who is that. Okay, so once I start showing this one, practically this detects is nothing but a sensor. Even if I'm rotating like this, now also it detects this is nothing but a sensor. If I'm showing the Arduino board, this detects as Arduino board. If I'm showing friendly arm, so these things, this is not an object recognition, this is an image processing, but the entire image itself, it's an object recognition, how the CNN is work. So this is a purely a classification algorithm. Okay, this is how that we need to focus. Okay, so while we are doing with some customers, okay, while we are doing with some customers for the retail industry, okay, what we did, we stimulated the data. Okay, so what we did is, okay, generally they'll be having an the infrastructure for the retail industry. This is for a European country. Okay, so they'll be having a retail industry. There they need to go and pick the food. Okay, no need to give the any no billing mechanism is there. Okay, once they are taking, okay, via the image recognition, it identifies. Okay, we are having all the pattern of the human is moving. Okay, and also we were connected to the different mechanism for all the food materials. Okay, if there is an, I mean, we are having a predefined image. If there is an image is moved, okay, from here to here, so there also it's recognized, and whether he's taking the food and he's keeping the box or not. So everything is we captured. Okay, so combinedly we are doing with the video processing, not with the image processing. Okay, so we did around 2018, think so, 18 or 2017 end. Okay, so we stimulated the data. Before connecting to the actual data, we need to stimulate the data. Okay, we need to generate the data with the same mechanism. Okay, so there we played a big role, and there also it gave a clear idea, and also it went to the market, and it's in the process. So there also we did, and also with the one shop, on food shop. Okay, so we received an the requirement, like we need to attract the people. Okay, okay, so there we were connected. Okay, so let's assume we are going to a coffee shop. Okay, the first time we are visiting the coffee shop. Okay, and they will be asking my name. Okay, so I'll be saying my name. I mean, while I'm billing, they will be asking my mobile number. Okay, same time they will be asking my phone number, my name also. So once I am doing the billing, okay, they are feeding my name as a Shabrinath. Okay, in the database. Okay, once they were feeding my name as a Shabrinath. Okay, after 1 month or 2 months, again, let's assume I took cappuccino on the day one. After 1 or 2 months, I'm visiting the same cafe. Okay, so once I entered, okay, the waiter directly comes to me and asking me that, okay, sir, you have ordered, last time you have ordered cappuccino. Okay, if you are ordering the same, okay, will be, I mean, thank you for, I mean, he is saying thank you for coming again. This is the second time that you are coming. Okay, so if you are ordering the same, okay, we'll give extra 20% discount or something else. Okay, so these are all the different mechanisms we added to the two different, and with the different the retail industries. Okay, this also comes under the retail industry. Okay, and we were connected, and there also we stimulated the data. Okay, this we were connected to the startups. Okay, this is what we kickstarted with the image processing stimulation. It's not simulation, it's stimulation. Okay, so these are all the things that we kickstarted, and we were connected to those industry, and we got an valid recognition. We got the necessary project. We got the necessary funds also. Okay. And similarly, while I'm connecting to the different image recognition, but it's hard to identify it. Even while we are doing a AMR, mixed reality or augmented reality, if I'm taking my mobile, I'm focusing my mobile, so then it's augmenting a glass over my eye. So there also it needs to identify my eye, the image recognition. Okay. It has to recognize this is nothing but eye. Then if I'm going forward, my eye will be big. If I'm going backward, my eye will be a bit small. So it has to recognize the same augmenting image should be dynamically matched such that it has to match my eye. Okay. There also the object recognition is playing a big role. Okay. So similarly, the object recognition is playing a big role for different industries. Okay. So even we are connecting to different predictor mechanism. Even the face everywhere, it's the same thing. And even I can able to share. I mean, if you are in Tamil Nadu, okay. If you are connecting in Chennai, okay. There is a training is happening in the Tamil Nadu government also. Okay, it's near Hindi. Okay, even if you need, I can give the exact address and share to him. Share to Dr. Arun. Okay. So if you need a startup training, you can able to get the startup training from there itself. Okay. There they are connecting the different mechanisms. The thing is, the asset is it's not a coding, it's an idea. Okay, how you are going to go ahead with your idea? Okay, how you are going to propose your idea? Okay, to connect a investor. Okay, so how your product can be recognized? How your product can be marketable? Okay, you can see a number of hackathons are there. Okay, even in Hackerspace and DevPost, I can see still at least 10 to 20 different hackathons are there. Okay, on live also, everything on live. Okay, the thing is, you need to tap those things and you can able to get it. So if I'm saying about the coding, all the coding is available everywhere. All the coding is available everywhere. Okay, so the one and only thing is, okay, how we are going to utilize those code. Okay, so if even I'm showing some chest X-ray with this, it identifies the COVID-19 also. Okay, so I'm showing those images. So these coding, everything is available. Okay, so the thing is, it's not the case that the how to code it. It's the case how to connect with the business case. Okay, how to connect with the earnings. Okay, how to convert your ideology into the money. So that's the challenge, or that's the thing that I'm explaining. Even I kickstarted with the normal electronics and machinery space, but whereas today I'm slowly migrated, and now it's a fully migrated into the data space. Okay, so I'll be connecting with the different machines. I'm recognizing the different data from the machines. So everything is doing from the machines only. So that's what I'm saying. Okay, we need to consider the more the necessary informations from the different industries like this. So you need to do, or you need to identify, or you need to tap a methodology from the industry. I mean, even if you are good in AR, VR, I'm ready to give one requirements also. Okay, that too with the object recognition. Okay, so if you are good in AR, VR, the requirement is readily available. I can able to connect with the corresponding industry. You can go ahead and connect. It's about you to connect, how to connect to that industry. I can guide those things. So I can give the direct contacts to you. So you can go and get the requirements. Okay. Then if you are capable, you have to give the necessary output and such a way that you can able to kickstart your startup and with advisable environment. So, or also if you are having if you are good in the breast cancers, I'm having a recommend in the breast cancers also. Okay, if you are good in defining the image processing, okay, it's not for the PhD project. This is for the recruitment process. So I'm not saying that I'm going to recruit you. If you are good enough, okay, we can able to recruit you. Here also the object recognition is required. Okay. So everywhere the object recognition is there. Okay. So the thing is how we are implementing, how we are focusing those things. So with the thought process, if you are having an ideology, okay, then practically you get rewarded from the different investor. Once the investors start focusing you, I'm sure that you are the key beneficiary. Okay. So that's what about the object recognition. Okay. So even if you want, I mean, better I share one more thing. So these things are all you might have seen in the Facebook also. Uh, so I'm trying to open where the code is. So it's getting open with the Colab. So if I run, practically it will take 20 to 30 minutes. I'm not going to run. Okay, I'm just show you. So actually, this is my brother's son. Okay, this is someone else. Okay, so this animation you might have seen. Actually, this is the image. Okay, so the facial change can be done with the DL. So most of you are all seen this, yeah, somewhat this video in Facebook or Twitter or somewhere else. But we can able to get this code. I'm not done this code. Okay, I just captured this code and I just pasted it into my PC and I converted this based on my customized process. So everything is available in the GitHub. So that's what I'm trying to say. Okay, so I think you got an base idea about how we can able to kickstart with the startup. The thing is, the coding technology is not a big thing. We can crack within 24 hours. The thing is, the idea matters. Okay, if you are having idea, we can able to migrate with the 4 or 5 different technology, and we can able to get the code, and we can able to deploy, and we can kickstart with the production. Okay, how we are going to start up? Okay, how we are going to initiate it? So that's the challenge. Okay, even if you are good in VR with motion tracking and everything, so I can able to refer some clients also. And if you are good in deep learning, okay, I can. I mean, if you are a student, I can give an interns. Okay. Again, if you are good, I'm ready to pay the stipends also, and even I'm ready to recruit also, provided if you are good. Provided if you are good. Okay. Uh, so opportunities everywhere. The thing is how we are focusing. So that's what I try to explain. I think if you are having a doubt, you can ask me. Okay. So I can be able to help you out. Okay. So please. Okay. If you are having doubt, Please ask. I can able to help you out.
Thank you, sir. So, participants, if you have any doubt, you just post the question in the chat box so that we'll notify you to the sir. The participants, you can ask the doubt.
Hello. Hello.
Yeah. Yes.
Yes, sir. This is Jayshree from Gujarat.
Yeah.
Uh,
Yes, ma'am.
yeah, I have heard you even previously also, and this time you have brought out a new dimension of startup. So basically, in our computer science field, right? Uh, what would we consider as startups? As such, you have already given up an idea by the demonstrations and your talk. But still,
Okay.
when we talk about core application side, we are in the MCA, right? So we want engineerings also, as well as maybe, other information technology guys also. So how, we can come up with that particular part, sir?
Okay. Okay. So practically, you are asking about you are having some team of students. Okay. You
Yes, sir.
are from the NCA.
Yes, sir.
No.
Yes, sir.
No. So how we can connect with the startup? Okay. So
Yes.
I'll share some of the link which is available from the Startup India. And even I
Hmm.
will share some of the hackathon links also.
Hmm.
Okay. So not the start Indian hackathon. Okay.
Hmm.
So, I mean not the government hackathon. Okay. Don't
Yes, sir.
mistake.
Yes, yes,
YMCA.
yes. Yeah, I
Okay.
understand.
So
Yes, sir.
please connect with the corporate hackathon. You
Hmm.
can these people can able to meet the different corporate people.
Hmm.
Okay, where the exposure of the student will change practically.
Yes.
So once the exposure is getting changed, then they can able to identify some problems, or they can able to receive some problems from the different corporate. Because so since I was in the manufacturing, I can see around 1,000+ problems from the manufacturing industry, but I can able to do the solution only for 10 to 15 problems only. Okay, for that
Absolutely.
also I'm not having the efficient man. Okay, so
Yes.
practically, even stating at least two, three problems itself, we can able to have a greater financial freedom. Okay, the objective of the startup is to get the passion and also to get the financial freedom. Okay,
Yes.
so if you are connecting to the necessary hackathon, practically I can show the day post hackathons. Okay, since it ends in 2021 also. Okay, so these are all the corporate hackathon. So even by seeing the prize money itself, you can able to see it. Okay, uh, so lots of hackathons are there. Okay, I'll share this link. Okay, and I'll share a few more links also. Okay, the thing is, if you are not having
Yes.
idea, connect with some of the hackathons. You can get an idea. Your idea gets focused and your idea get narrowed down. If you
Definitely.
have idea,
Yes, sir.
you can able to build the solution. Okay,
Yes.
connecting the
Yes, sir.
hackathon, your skill will be converted into idea for particular idea, and it will be converted into your corporate.
Yes. Thank you so much, sir.
Thank you, thank you, thank you.
Thank you, sir.
So if you are having doubt, please. Okay. Okay, I like to thank the, I think the doubt is clear. I like to thank the management and the corresponding HOD and Professor Arun and few more faculties also. Okay, connecting me to, I mean, especially the participants actually, sorry. Okay, so to connecting me and sharing my thought process in the data recognition. Even I will be sharing the data, I mean, pattern recognition. Okay, so on that day, I'll be showing the live pattern recognition, how we are monitoring. Okay, even connecting to the stock market to the different algo mechanism. Okay, how we are doing. So these things are all will be focusing on day after tomorrow. Okay, I'll show the live demo also. Okay, so doing programming is not a big task. Connecting the ideology is a big task. So again, I'll thank everyone and I'll thank all. Okay.
Thank you so much, sir. Definitely, it's a thought-provoking session. We got a lot of positive feedbacks from the participant side in the chat box as well. Okay, thank you for sharing your valuable knowledge and time for us, sir. And as a token of gratitude, we would like to present a visual memento. Kindly accept this visual memento, sir.
Sure, sure.
I'll start to present it. Okay. Just a minute. Okay, sir.
Thank you, ma'am.
Yeah, thank you so much, sir. Okay,
Okay.
so participants, the feedback has been posted in chat box. Kindly fill up the feedback, and once you fill the feedback, you can leave. And tomorrow's session will be sharply starts by 10 o'clock, 10 a.m. using the same link that you can rejoin it. Thank you, everyone.
Thank you, sir. Thank you for your valuable lessons once again. Thank you all participants for joining us.